Okay, thank you. Seems to work, and it's first of all very nice to be here in this very pleasant climate. I'm almost getting used to it. We get this hot somewhere in the middle of July, and maybe for 10 days. So lucky you. And can we also get a little bit the light off like before? Great. So what is very interesting here is that actually the 2015, and I already said that for several years ago, that we are living in the age of the most impressive achievements. And it's interesting that in all the science, and especially in medicine, as we also heard some examples of the previous lecture, and chemistry and digital technologies, they're all kind of merging together, and it's changing also our understanding of the organizational logics, how things are being put together, what are the new uses for. And I think interesting is that the computing and the genetic engineering are now shaking hands already for almost 2 decades with the advance of the computer power. And it's interesting that also this machine is powerful enough to run since 2007, and it's doing amazing jobs still up today. If you know how to program them and how to get them working. And it's very funny that sometimes some unrealistic things like this human's ear grown to a rat, which was supposed to be a joke, is being picked up by Hollywood or by movie industry, and it's being shown like less than 1 year later in a fiction series, CSI New York. And it's interesting that the architecture, if we classify it somehow through the chronology, the formal system, how it's being built, and also how the material works, then for many centuries, until 1900, all the materials were put vertically on top of each other, like pyramids in Egypt, the same, like stone on a stone on a stone. This morning, looking out of the window, I saw very good. Still here? See the cable? Okay, it's better. So I was looking out of the window this morning here outside when they are building the new 20-story high-rise, well, low-rise buildings. That now we're working on the horizontalization, where all the tension structure is put inside of the concrete with a metal substructure, which is kind of elastic, and it doesn't allow the house to be torn apart. The future, which is the so-called genetic future, is very interesting that we have the organic forms already being produced. We don't speak here anymore about some concepts, but about real things happening. And it's very obvious that the structures will be living, and it's not maybe in the mainstream, in the housing architecture, in houses where people live and reside, but maybe we're just one step towards it as well. And the third stage will make all kind of design possible. Here we could have some grown bones and tissue structure from human flesh and so on. And we can look that we are already using some of these automized production systems in forms of the CNC machines, which actually run some kind of script that's being put into them. And when we are now stepping towards the big changes, actually it's funny that the definition of architecture itself is finding new ways. Cannot touch this. So I better stand here. We are transforming a lot together with the society, also politics and economics, and many concepts now are transforming in the world, and it's maybe called the new expressions, but it's interesting that there is also a new definition for it. It's called digital organism, which could be said that it's this century's new architecture's avant-garde. And it means that we have the computerized graphical means to express the ideas, and then we have the tools at the same time without paperwork that can produce these things. First of all in laboratories, then in bigger scales, and maybe finally one day also in urban planning, designing whole cities and the structure, how it works. And it's interesting that also some skeptical namings of these new expressions that are built in our cities have been found. I know the London's Cucumber building, everyone knows it, right? You've heard of that, but people also call them bubble or egg architectural forms and so on. And they're kind of pointing at these bulging forms that are made by all these computerized means, and maybe that's partly because of lack of understanding that there's something much more behind that, or maybe that's not yet very much demanded and not very much popular in our society. The first who mentioned genetic architecture, and here comes the interesting part. I was 10 in 1992 when already this term was coined or picked up by architect Carl Chu. And he was actually forming a new theory for architects, which is influenced from knowledge of mathematics, physics, philosophy, and metaphysics. And what's interesting that this man has done a lot of research on evolutionary cosmologies, which basically are based on metaphysics and computation somehow mixed together. And the computation is also understood here as the physical universe's feature in the conceptualization, and it's converging together with genetics. And finally, it gives us a theory which can be used and which is based on the so-called possible worlds, which can transform our world. And the concept here that's just fall on his fingers, in his fingertips, was made some almost 7 years ago when I started to go into this subject, where it's actually kind of examining abstract systems. Well, abstract it's until a time when we get it out 3D printed or using some part of it. And what's interesting that very simplistic substructure makes it. And it's not so that we use, let's say, AutoCAD for engineers or for architects, which have these very, very limited tools. But we use three-dimensional modeling, and we use software where there is a lot of more advantages for three-dimensional form to get it under control. And it's interesting that basically there's not ready-made solution yet, and we're in 2015, but there start to appear all kind of these plugins. One of the most beautiful tools, I think, maybe hasn't spoken of all its capacities yet, is Grasshopper, which is actually a plugin for Rhinoceros, which is used very much for industrial design, all kind of scales, starting from very small pieces up to very large scale, and it can be programmed, and some people call it like scripting. And if the correct tools are here, the genetic architecture basically is a code which starts to replicate itself. And here, if we interpret in a visual three-dimensional environment each of the letter, like A, B, C, and D, in its direction in the space, we can define the geometries to be grown out of these very simplistic things. Like it's so that we go from point A to point B, which is somewhere in space, then from point B to D, then back to C, and then we repeat this. This is like one small branch, could be my hand, from here to there, and then there's another branch in it, and then another. And when this all is being mixed together, if we express it, and if we choose to do so, we can give this very, very, maybe too much simplistic algorithm. But that's the idea where the reason comes why we call it genetic architecture, that this is kind of genetic code. Our bodies also run on genetics, and which are being inherited from generation to generation, and the whole code consists of 4 letters only, but just that it's being put in different order, and one of them gives better character, some gives different one, and then when we feed this body of human organism with a different food, it may react differently. Well, that's what's happening in nature. So later, when we join this together and we start kind of making and repeating it like numerous times, we start getting hybrid form. that can be expressed by some openings and some closed surfaces. And when we just let these smaller to bigger to very big structures, and then we open a very old book, like more than 100 years old anatomical book or research of human lung, we actually come up to the structure of something that's used for breathing. And what's most interesting is that this is an organism, could be a virtual organism, could maybe substitute your lung or your heart or whatever, a prototype for some futuristic creature. Please don't let them out into the society too early, but I understand this as a joke. But if you look closely, then actually the complexity of form, if we interpret, and here I just choose very anatomical colors, and the shape is actually very profoundly original, and it's not anymore looking like 4 letters. We just have gone a little bit a step further, giving it like surface, and then giving it materiality. Could be that we could grow using the same Radiolarian substructure, grow some tissue on top of it, and get to some results. And it's interesting if we cut apart the newly made object, we could have maybe these lines here could have something to do with a new Bilbao museum in Tel Aviv. I just threw out an idea. It's maybe already being made, but could be also this one. And when you cut it apart in this was longitudinal. When you do it the same in the lateral way, it reveals more of its three-dimensionality, and it's almost like Ido's lecture before, where he took something realistic made by a bird, like bird's nest, and then 3D scanned. Well, this is like if that was top-down design, and this is bottom-up design, where we design from scratch some new forms. Where it helps, actually, it helps when architects are sort of fed up with design solutions where the client comes and they cannot get to a solution. Then maybe genetic architecture can help. And there's already a new, for designer, like for an architect or for industrial designer, whoever, okay, sorry, cannot touch that. Then whoever wishes to find the so-called emergent design, then it's actually a mixture. It's like multidisciplinary field, somewhere between the artificial life, between the evolutionary computation, and also, of course, between design. And if we find this new paradigm in architecture, then basically the existing systems are not very generative or creative at the moment. But if we basically use these powerful tools, we can get a little bit further. But of course, the architect has need to come up with his own idea how to program these kind of things. And we're basically one step closer to the genetic architecture. And it's interesting that this makes possibility to cooperate from totally different fields. There are already emerging architects' offices where there's a designer architect, and there's some conceptual thinker, maybe philosopher, and even a poet or musician, because from this thing you can make out also the sound, you can program music. There is genetic music already ongoing. You can listen for it like for thousands of hours, and it will continue evolving its own way. And in the international stage, the term genetics is used together with architecture, more or less, starting from year 2000. So it's not very new things I'm telling on here, because there are several master programs in architecture already teaching this in Architectural Association in London, in Catalonia University in Barcelona, and several more in the United States as well. And so the genetic architecture basically is very much dependent of the software, which usually is being borrowed from other fields, because the software I'm mostly using, Autodesk Maya, is being used for three-dimensional effects in Hollywood and movie industry, in cartoon industry, and also in industrial design as well. Maybe it's not so compatible, but the years show that it's very good field to do that. And we're kind of paving the way for this advent of genetic architecture that I can say has already begun. And with this little theoretical thoughts, take this as a very good example that music videos already use robotics and this 3D printed human and artificial intellect that's maybe one day will also come into our life. And this is actually a very old music video, I think also from 2007 by Björk. I will not put a sound on, otherwise this turns into a party, but thank you very much for the insight, for inviting here. And I'm looking also towards the works exhibited today, the opening at 4. Thank you very much.